go. Okay, today what you're gonna do is we're gonna look at polynomials, and we're gonna be able to factor them completely and find all of the zeros. Because tomorrow you're gonna start graphing these. Okay, so you're gonna be given a polynomial and you're gonna have to be able to break it up completely. First of all, you need to know the difference between what a rational and a real zero is. A rational zero are zeros that look like 1, 2,
Even
3, -1, -2, -3, 0. Those are the rationals, okay? A rational number is a number that can be written as a ratio of two integers. It could be a half. A half is a rational zero. So a half, a third, a fourth, and then numbers like 1, 2, 3, -1, -2, -3. So any number that can be written as a ratio of two integers, ratio of two integers, like plus or minus 1, plus or minus 2, plus or minus 3, and then all the fractions, 1/2, a third, a fourth, any decimal that ends or repeats. What is an irrational number? An irrational number is like the square root of 2. Or if you're solving, for example, if you had something like this, if you had x squared minus 2 equals 0, and you were asked to solve this, what would you do? You would add 2 to both sides and then take the square root. So these two zeros, which are plus or minus root 2, these are irrational. So they look like ones like plus, these are the numbers that if you would have to take a calculator out and convert it to a decimal, and you would see that it does not repeat. They're non-terminating, non-ending numbers. Like plus or minus root 2. These are the ones that look like this. 1 plus or minus root 2 over 3. Those are examples of irrational. Now, pi is an irrational number. Pi is an irrational number. What about if I gave you this? X squared plus 2 equals 0. And you solved it by subtracting 2. What kind of zeros are these? Square root of -2. Imaginary. So these are not rational, they're not irrational, they're imaginary. So we're not talking about the imaginary zeros, not yet. We're looking for these two kinds of zeros. These are real zeros, rational and irrational. So now, when you go to solve these polynomials, there's several ways to find the zeros. The most common way that we know very well is by simply factoring it. We can complete this, we can take the difference of two perfect squares, a perfect square trinomial. But if it's not factorable, we have to whip out one of these three. One of these three, the quadratic formula, or complete the square, or take the square root of both sides. We could use a graphing calculator, but we're not going to. But that is a possibility. And the last item that we really haven't investigated thus far is using the rational zero test and synthetic division. You have to use synthetic division along with the rational zero test in order to factor them and find all the rational and real zeros. So you want to use this test right here when you have polynomials that are above and beyond the quadratic. So when you have x to the third and higher, you have to use number 6. Okay? So we use these ones when we have x squared. And then we're going to use this one for the rest, and that's what we're concentrating on today. So, not all polynomials are factorable. So what we have here is this rational root theorem, And what you're gonna do is you are going to take factors of your constant term and you're gonna divide factors of the leading coefficient. These are the possible zeros, and then what you have to do is one at a time take that list, and you have to use synthetic division to see where you get a zero remainder. So these are the steps. Number one, make sure that your polynomial is written in standard form. Standard form is with the highest degree first and then going down. And always look if there's any missing terms. Like for example, if it jumps from x to the fourth to x squared, you want to put a 0 for x cubed. Then what you're going to do is list your factors of the constant term. Do you remember which one's the constant term? The constant is the one that doesn't have a variable. And every single one will have a constant. And it's not going to be 0. Okay? It's going to be a number other than 0. So we're going to refer to the constant term as the p-value. And then you're going to look for the leading coefficient. That's the number in front of the biggest term. That's your q value. You're going to combine fractions of p over q, and then you're going to use synthetic division to start testing them till you find a 0 at the end. And then when you get down to it, you're going to use the quadratic formula or complete the square or take the square root of both sides when you end up with an x squared problem. Okay? So let's try the first example. Okay, here's your polynomial. I want to find all the rational or irrational zeros. So it's in standard form, 3, 2, 1, and 3. 3 is your constant. So when I refer to the p-value, this is the p-value I'm talking about, 3. P is 3. When I refer to the q value, q is going to be the leading coefficient, which is 1. So what you have to do is make a fraction, and the fraction is all of the factors of 3. What are the factors of 3? We have plus or minus 1 and plus or minus 3 over factors of 1, which are plus or minus 1. So what kind of combinations are you coming up with? We have 1 over 1, which is 1, 1 over negative 1, which is negative 1, 3 over 1, which is 3, and negative 3 over 1, which is negative 3. That's it. So does everyone understand the possible? These are your like you wouldn't test 5. 5 is not a possibility. It's 1s or 3. 1 over 1, 3 over 1. And you do plus or minus. So now what you're going to do is you are going to take one at a time, and you're going to use synthetic division. So I always try 1 first. 1, we call this the C value. This is your C value. So in order, in case there's 1 missing, put a 0. So your coefficients are 1, 5, 7, and 3. Now, how do you do synthetic division? You bring the 1 down and you multiply. What's 1 times 1? 1. Then you add these, you get 6. You multiply, add, multiply, and add. And this is your remainder. So is 1 a 0? No, it is not, because we didn't generate a remainder of 0. We want to find a 0 right here. Now I have a test for you. It's called the upper and lower bound. So our numbers were -3. This is our test. If I had to organize them in order from least to greatest, we tested, these are the possibilities. We tested 1. If you test a positive number, so in other words, these 2 C values are positive and these 2 C values are negative. If you test a positive number and at the bottom you get all positives, 1 is considered an upper bound. That number, that C value that you tested, is an upper bound. It's too big. Try something smaller. So if 1 is too big, would you try 3? No. If 1 is too big, 3 is bigger. So what is this saying? 1 is an upper bound, it's 2. When you test a positive number, and all of these are positive, that was too big. So throw out anything bigger than that. So where do we have to go? We have to go the other direction. So what am I going to do? I'm going to test -1. Try -1 and see what you get. -1. We're going to use 1, 5, 7, and 3 again. Bring down the 1. -1 times 1 is -1. Add. Multiply, you get -4. Add. Multiply, and guess what we got? A 0. So, -1 is a 0. -1 is a 0. So if I wanted to write this in factored form, I'm going to take the opposite of this and write x plus 1, because -1 is a 0. So if the 0 is -1, in factored form it's x plus 1. What's left here is the coefficients. You go 1 degree less than this, so it's going to be 1x squared plus 4x plus 3. Now, once you get your polynomial to an x squared place, which is right here, now you're going to try to see if you can simply factor it, use the quadratic formula, complete the square. Is this simply factorable?
Mm-hmm.
How do you factor it? Yep. So now, if I ask you to factor it completely, that's factored completely. Is there a shorter way to write this answer? X plus 1 quantity squared. So in other words, the 0, -1 occurred twice. It has a multiplicity that's even. So at the 0, when we get to it, we're gonna talk about the multiplicity of each 0. It's gonna touch at -1 and then x plus 3. So if I ask you, state the rational zeros, you'd say -1 and -3. And these happen to be real also. There are no irrational ones for this problem. We factored it completely. So the zeros are -1 and -3. You guys remember doing this stuff? Okay, let's try another one. Okay, so what's my p-value? 3. And what's my q? 1. We're going to do plus or minus 1, plus or minus 3, over plus or minus 1. So what are my choices? -3, -1, again, 1 and 3.
Is it always over plus or minus 1?
Well, if the leading coefficient's a 1, then yes, it'll be plus or minus 1. I always start right in the middle at 1. So start with 1. Let's see what we get. We've got 1, -1, -3, and 3. So bring down the 1. 1 times 1 is 1. Add, multiply, and guess what? We got a 0. So 1 is a 0. So if I start writing it in factored form, I get x minus 1. What's left here is x squared plus 0x minus 3. Now what do you do right here? How do I find these two zeros? What do I do? This is really easy. You're going to set this equal to 0, add 3, square root both sides, and what two answers do you get here? Plus or minus the square root of 3. What kind of zeros are these two? Irrational. These are irrational. So, how do you write this in factored form? You're going to have x, bring down your x minus 1, that's this right here. And now how do you incorporate these? You're going to write x, it's always the opposite of your zeros. So square root of 3, and x minus, we have negative square root of 3. So in other words, plus and minus the square root of 3. So this is in factored form. We factored it completely. What are the rational zeros? The rational zeros would be 1 And the irrational ones would be square root of 3 and negative square root of 3. Questions? Let's try another one, number 3. I don't see a constant term, do you? Anybody see a constant?
Is it 0?
Huh? It's not gonna be a 0. Your constant will not be a 0. What should we do first? Take out what? X cubed, good job. Always see if you can factor something completely, GCF something out. And it's x cubed. So you have 2x to the third minus 3x squared minus 7x minus 6. Now, we found 3 of our zeros, which happen to be 0. You got 0, 0, 0. This has a multiplicity that's odd. It's going to cross through at 0. There's 3 more zeros here, inside here. So we're going to factor this completely, this piece right here. So I need my p value, which is 6, and my q value is 2. So what are your possibilities? What numbers go into 6? 1 goes into 6, 2 goes into 6, 3 goes into 6, and obviously 6 goes into 6. And then what are your factors of 2? 1 and 2. Now look at this crazy list. We've got a 1, a negative 1, a 2, a negative 2, a 3, a negative 3, a 6, a negative 6, and then you've got 1/2. 2 over 2 is 1, we already said 1, then you got 3 halves, and 6 over 2 is 3. You got a long list. This is where the upper and lower bound is going to help you out. So, how do you know what the upper and lower bound is? If you test a number, let's say I tested 1, and I ended up getting all, if you look at the next page, I have it listed here, what the upper and lower bound is. So, you're going to use this upper and lower bound test on types of problems like this where the list is just crazy. You've got a lot of possibilities. You don't want to go crazy with all these numbers, so it's nice to have a hint. So here's your hint. If the C value, these are the possible numbers that you're testing. If you test a positive number and you get all positive numbers at the bottom, that number's too big. That's called an upper bound number. So don't do anything larger than 3 because 3 is too big, so don't try 4, 5, 6, 7, 8, whatever's in your possible list. Now, what if you test a negative number? If you see this checkerboard, a positive, the alternating signs. Now, it can be positive, negative, positive, negative, positive, negative, or it could be negative, positive, negative, positive, negative, like that. If you test a negative number and you get this opposite signs at the bottom when you're doing synthetic division, that number is a lower bound. It's too small. Go the other way. So don't try numbers like negative 5, negative 6, negative 7. Go the other way. Go bigger. So this is like little hints for you if you see that. So let's try, for example, 3. I always start with 1. And you may want to write small in case you end up having to test a lot of numbers. But you're going to use these numbers, 2, negative 3, negative 7, and negative 6. 2, negative 3, negative 7, and negative 6. I'll make this a little smaller. Okay, so bring down the 2. 1 times 2 is 2. Add, multiply, add, multiply, and I already know this isn't going to work. I get negative 14 here. Sometimes I stop like right there. If I know, I just don't finish it. If I know I'm not going to get a 0. So try 2. I'm going to go, now I don't have an upper or lower bound. If these were all positive numbers, 1 would have been an upper bound. I wouldn't try 2, 3, or 6. So let's try 2. I got 2, -3, -7, and -6. So I'm gonna bring down 2. 2 times 2 is 4, add, get 1, 2, -5, and again, nope. Not, let's try 3. Haven't found an upper bound yet. 2, -3, -7, -6. So 2 times 3 is 6, add 9, 2, and 6, we got it. Bingo, we found our first answer. So now, we're gonna keep a running total here. We've got x cubed. Now, what was our next 0? 3, so you're gonna write x what? Good, -3. Now, what's left here? We've got 2x, what? 2x squared. You go 1 degree less than this. Remember, these are the coefficients 1 degree less than what you started with. So 2x squared plus 3x plus 2. Are you guys with me? Now, what should I do at this position right here? I want to break this up. What should I kick out? The quadratic formula. Why? Can I complete the square? You could, but there's a 2 here, and that's an odd number. I'd stay away from complete the square. I would use the quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. Try that. So we have 2 more zeros we need to see if we can unlock here. We've got we're going to do -3 plus or minus, the b value squared is 9, minus 4 times 2 times 2. So what are we looking for? We're looking for real zeros. What did you find? Did you find any real zeros here? Did you find any real zeros? I haven't heard
No.
yet. Why? Why aren't these real? Yes, you have a negative under the square root. These are not real. These are imaginary. We're looking for real. Real would be a plus. If this were a +7, these would be irrational zeros. So this would be under the irrational column. So the answers to the questions, it says find all rational zeros. The rational zeros for this problem would be 0 and 3. And they would also be real, 0 and 3. But these two are imaginary. So if they ask you to write it in factored form, factor it completely, that's the answer. X cubed times x minus 3 times 2x squared plus 3x plus 2. Now what if, let me just say this really quick, because these problems take forever to do, and you notice I didn't give you a lot. What if I asked you to factor this completely, and let's pretend like this -7 were a +7. So let's say, just for fun, let's say this answer was x equals, for these two right here, I got -3 plus or minus the square root of 7 over, what is it, 4? Okay. Let's say we got a +7. How would you write this in factored form? This is how you'll write it. X cubed, and then x minus 3, and then x minus, you're going to write -3 plus the square root of 7 over 4, and x minus -3 minus the square root of 7. Just leave it just like this. That's how you would write it factored completely. And it's always these are always minus, and then you have your 2 zeros. A lot of people get confused by this. You don't worry about distributing it. I want you to leave it like this, so I can see your zeros. Yeah.
When we're going through the list and doing some type of division, once we find a number, we can stop. We're gonna have to keep going.
No, you have to keep going till you break it up completely.
Well, like,
So you want to look at this, you want to look for 6 zeros. We got 3 zeros, so 3. We have 3 of them so far. Then we found our fourth one, 4. and then 5 and 6, but these are imaginary. So you wanna break them up till you're done.
But like, we wouldn't go back and do -1, -2.
Oh, no, you're done here. We've exhausted everything we possibly could.
Okay.
Okay, okay, we're gonna do one more. Example 4. Okay, what are your possible what's your p-value? 2. What's your q-value? 1. So this is a short list. 1, 2, over 1. Now, the reason why I have this one is because your list now is so short that one of these zeros might occur twice. So just because you tested a number, it might occur more than once, and that's when we talk about multiplicity. So let's try 1. Let's try 1 in this problem. We have 1, -2, +2, then what? Good. 0, -3, and 2. A lot of people forget that, and it will mess you up. So bring down the 1. 1 times 1 is 1. Add, multiply, add, multiply, add, multiply, add, multiply, add. Whew, got it. It worked. I mean, there's not many to choose from, so. So now at this point, I could try 1 again. So let's start breaking it up. We have, if 1 works, we've got x minus 1. What's left here? This is going to be 1x to the 4th minus x cubed plus x squared plus x, and then minus 2. So now we're going to break this up. There's 4 possible zeros in here. I'm going to try 1 again. Let's see if 1 works again. So now we use these numbers. Don't go back to the original. Use 1, -1. You're using these right here. So 1, -1, 1, 1, and -2. Let's try this. Bring down the 1. 1 times 1 is 1. Add, multiply, add, multiply, add, and guess what? It worked again. So you've got x minus 1 and another x minus 1. What's left here would be x cubed plus x. Is this squared? What is it? It's just x. This is x squared. This is x, and then 2. Now we can try 1 again. Let's see if 1 works again. So we're going to do a 1, a 0, a 1, and a 2. 1, 1, 1, 1, 2. So guess what? Now this is an upper bound. So we're not going to try 2. Let's try -1. Let's try -1, see if that works. So we're going to use -1, and we have these, 1, 0, 1, and 2. So we have a 1, multiply, add, multiply, add, multiply, and guess what? We found it. So we've got, what did we have? We had x minus 1 quantity squared, because there were 2 of them. Since this one works, what are you going to write now? X plus 1. And now what's this? This is going to be x squared minus 1x plus 2. So this is what you have here. This goes with this. And now there's 2 more zeros, possible ones. What are you going to do at this point? -b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to use the quadratic formula to see what kind of numbers I get here. So it's 1 plus or minus 1 minus 4 times 1 times 2. What do you notice again? This is going to be a negative here. You're going to have negative 7. And again, these are imaginary. These are imaginary zeros. And so I'm done. There's nothing else to try. So what are the answers to my questions? Question A says, find all the rational zeros. The rational zeros would be 1 and -1. The real zeros would be 1 and -1. This is writing it in factored form completely, and there are no irrational zeros. You guys get this? All right, now, I'm gonna let you guys work on your homework for the last 20 minutes, but check out number 7 and 11. What is up with 7 and 11? Do you see integers for the coefficients? What are these are fractions. You want integer coefficients. So what would you multiply everything by to get rid of the 12 and the 12 and the 3? 12. So if you multiply this whole thing by 12, tell me what you get. You get 1x cubed minus x squared minus 8x and then plus 12. Everyone get that? So now you're going to do this problem. So your p-value is 12 and their q-value is 1. So work on breaking this up. And then what about number 11? What's up with 11? What should you multiply everything by? 10. So if you move this decimal over 1, this over 1, you'd add a 0 here. You end up with x cubed minus 19x plus what? 30. So your p-value is 30. So you're going to do test 1, 2, 3, 5, 6, right? What else? 10. So this one you might find it fast, but you might want to use the upper and lower bound because when you get numbers like that, it gets crazy. So all you have to do in 13 through 17, it just says, I just want you to factor it. Just factor it. You're going to write it. You're going to find the zeros and write it like that. Factor it completely. Okay? There's not a lot of room on this paper. I didn't want to use a whole nother sheet of paper, so either write really small, or you might want to attach a separate sheet of paper to do all your synthetic division. Okay? All right.